Hello students, welcome to Educate. In previous lecture we have studied about connected body motion. Today we are going to study friction. So you know about friction very well, and you must have felt that in absence of friction what happens. If your leg falls on banana skin, then you slip. Similarly, other phenomena you must have observed. So let's see the definition. Friction is a force. Friction is a force that opposes the relative motion or tendency of motion between two surfaces in contact. It arises due to the microscopic roughness of surfaces and the molecular interactions between them. The main causes of friction are surface roughness, adhesive forces between molecules, and the deformation of the surfaces. Now let's see the types of frictions. First one is static friction. When object is not in motion, this type of friction occurs when there is no relative motion between the surfaces in contact. It prevents an object from starting to move when a force is applied to it. Then comes kinetic friction. When body is set into motion, then during that motion there is certain friction that is called dynamic friction or kinetic friction, but it is less than static friction. Then comes rolling friction. When a body rolls in contact with another surface, then the friction that comes into play is called rolling friction. Fluid friction, you know, viscous force between two layers of fluid will try to prevent the motion of the liquid. This happens in case of gas also. So we will study about viscosity in the chapter fluid mechanics. Now static friction is self-adjusting force. It means suppose there is a body and here it is kept on the ground and you are pushing it with certain force. Suppose you have applied force 10 Newton and body does not move. It means friction is limited to 10 Newton. Now if you increase the force, suppose it becomes 15 Newton, still body does not move. It means friction is 15 Newton. What you have observed? Friction is adjusting. Here the term is static friction is self-adjusting force. Suppose you apply 20 Newton force, still body does not move. It means friction is 20 Newton. Now suppose force is 21 Newton and body starts moving, then you can say that this is the limit of static friction. So this is called limiting friction. Limiting friction means highest value of static friction. So through graph, if you see it, so you will notice that it will be like this, and after reaching a peak, this will be limiting friction, then body starts moving and friction reduces, and then here this is kinetic friction. So this is limiting friction, which is highest value of static friction. This portion is static friction. So here same thing is given. So static friction adapts itself to match the external force, making it a self-adjusting force that maintains equilibrium until motion is initiated. So here there is one question. A block of mass 2 kg is placed on the floor. The coefficient of static friction is given 0.4. A force of magnitude 2.5 Newton is applied to it. What is the force of friction between the block and the floor? So static friction, just evaluate limiting friction. So let's write it as so mu times mg. Here mu is coefficient of friction. So value of coefficient of friction is given as 0.4. and mass of body is given 2 kg, and the value of G you can take either 9.8 or 10. Let's take 9.8. So this much Newton. So here applied force is given, force of limiting friction you can evaluate, that comes out to be this much. So question is, if limiting friction is this much, 7.84 Newton, and applied force that is limited up to 2.5 Newton, then what will be the value of friction? So as you have studied that this static friction is self-adjusting force. So whatever force you apply until body starts moving, that will be called friction. So here friction will be limited to 2.5 Newton only, even if limiting friction is this much. Limiting friction means this is the highest value of friction at which, after which body will start moving. So that does not matter. Now graphically the same thing is shown here. As I told you earlier, this is force of friction in this direction, this is applied force. So this is the point that corresponds to limiting friction. After that body will start moving. This is portion that corresponds to kinetic friction. This is kinetic friction. Either you can write Fk, that will be better, and this is friction static, so Fs. So you have understood this is highest value. Then let's see laws of friction. Laws of limiting friction. The laws of limiting friction describes the relationship between the force needed to initiate motion, limiting friction, and the force pressing the surfaces together. There are two main laws. Number one, the force of limiting friction is directly proportional to the normal force pressing the surfaces. First thing, friction is directly proportional to normal force, means mg, and we can write frictional force equal to mu times, this is normal reaction, so frictional force is mu times normal reaction. Normal reaction R is weight of the body, so mu mg we can write. Now here the force of limiting friction is independent of the apparent area of contact. It does not depend on the area of contact. This means that as long as the normal force and the coefficient of static friction remains constant, the force needed to initiate motion will not change regardless of the contact area. So it does not depend on area of contact. It seems that it does depend on area of contact, but it is not the case. Then comes laws of kinetic friction. When body is in motion, in that case, force of kinetic friction is directly proportional to the normal reaction, pressing the surface together. Same thing, but this time, earlier it was coefficient of limiting friction here, and then normal reaction was there. The same thing is happening here. This is coefficient of kinetic friction, whose value will be less than the coefficient of static friction. Then force of limiting friction is independent of the apparent area. The same situation is given here. Now let's see what is angle of friction. So angle of friction, this is direction of friction, this is normal reaction. What is normal reaction? So normal reaction means, suppose weight of body is acting downward, mg, then just against it there is normal reaction, written as R or sometimes capital L. So we can say R equal to mg. Later on this R will change when body will be on an inclined plane, so its value will change. In that case it can be R cos theta, etc. That we will see according to the situation. So here what is happening? Here our concern is to find out the angle of friction. So angle of friction, this is normal reaction, this is direction of friction, and this line represents the resultant of these two. So angle between the resultant of normal reaction and friction and the normal reaction itself is called angle of friction. So tan theta, if we want to find out, so what will be perpendicular? Perpendicular will be AC. AC means this friction, and this is normal reaction. So ratio of the two, friction upon normal reaction, and that will give coefficient of static friction or coefficient of friction. Now, angle of repose. Angle of repose means what? It is the situation when body is just at the point of slide. If this angle increases a little, body will start sliding. So it is at the point of slide, it is not sliding. So here we can analyze the situation. So here it is clear, this is body of mass m, its weight will act in a downward direction, and in this direction it will be mg cos alpha. So here normal reaction will be in this direction, it will be r, and in this direction there will be one force, that will be mg sin alpha. Here if we want to find out this angle theta, so we can write it, friction will be here limiting friction, here friction will be mg sin alpha, normal reaction will be, as I told you, r equal to mg cos alpha. If you divide the two, f limiting friction divided by f this normal reaction, you will get mg sin alpha divided by mg cos alpha will give tan alpha, which is mu s. But if you remember tan theta equal to mu s, so you can say tan alpha and tan theta both are same. It means angle of friction equal to angle of repose. I think you have understood. Now let's go to next situation. A body rolled on ice with a velocity of 10 meter per second comes to rest after traveling 4 meter. Calculate the coefficient of friction. Here velocity is given. So initial velocity is given as 10 meter per second and final velocity is 0 because body comes to rest. So u is given as 10 meter per second and v equal to 0, and the distance s is given as 4 meter. We can apply v square equal to u square plus 2as. So if we evaluate it, what do we get? So 0 equal to u square means 100 plus 2 into a into distance is 4. So we can divide it. So what will it become? A equal to minus 100 divided by 8, which will be minus 12.5 meter per second square. So this is acceleration, but A equal to mu times g. So taking positive value, 12.5 equal to A times, A equal to mu g. Mu is given here, mu is to be found, g is 9.8. So mu can be found 12.5 divided by 9.8. So here same thing is explained. Mu equal to A upon G or A equal to mu G, same. But you have to check the calculation once. V square 10 meter per second square. Here value of u is given, v is 0, comes to rest, and s is 4. So A will be this much, and after that you can evaluate. Now let's take another question. Find the power of an engine which can maintain its speed. Here language is wrong. Find the power of an engine which can maintain its speed of 50 meter per second for a train of mass 3 into 10 power 5 kg on a rough incline. The coefficient of friction is 0.05. Take a G equal to 10 meter per second square. So here, first of all, we have to evaluate what is frictional force, and then power can be found by multiplying frictional force times velocity. So in our question, velocity is given 50 meter per second. So V is given 50 meter per second, and we need coefficient of friction Fr. So for that, let's evaluate. So Fr equal to mu. Mu is given as 0.05 into mass is given 3 into 10 to the power 5 into G is 10. So frictional force will be equal to, you can cancel 110 here and 110 here. So 10 power 4 will be there. So 5 into 10 to the power 4 Newton. This is frictional force, and now we need power. So power equal to force into velocity. So force equal to how much? 5 into 10 to the power 4 into velocity is given as 50. Then you can multiply it, answer will be what. If you have doubt why power equal to force into velocity, so that I can tell you. So see, power is work upon time. Force into displacement divided by time. If you remember, displacement upon time is velocity, so force into velocity. So here in our question, it is simple. First of all, we have to find out frictional force. Frictional force, as you know, so Fr is mu mg, and after that, this frictional force is multiplied to velocity to get the power of engine. Now, work done in sliding a body over a horizontal surface. So suppose you are pulling the object, so definitely there will be opposing force. So you can calculate that opposing force, and then work done will be equal to that opposing force times distance moved. So first of all, we find out the force of friction. Force of friction is normal mu times mg, and suppose body moves through a distance s, then work will be Fr times s. So it is simple thing. Now calculate the work done if a body of mass 10 kg moves through a distance of 2 meters on a rough horizontal surface having mu k equal to 0.25. So question is very simple. W equal to mu k times mg into s. Mu k is given in our question. Mass of the body is 10 kg, g is 9.8 meter per second square, and distance moved is given 2 meters. So you can easily evaluate. So that was the case when body was moving on horizontal surface. Now there is another case when body is moving on an inclined plane. Work done in moving a body up an inclined plane. So as you know, in case of inclined plane, one force mg sin theta will act downward along the incline, and here you are applying the force F. So net force applied by you will be P minus mg sin theta, and whatever distance it moves, you can evaluate. Here, one more thing you have to take into consideration, that suppose you are applying force P in this direction, mg sine theta is acting in this direction, friction will also act in this direction. So there are two forces that are opposing your force. So you can say net force will be difference of these two forces, frictional force plus mg sine theta. Now there is another question, what will be frictional force in this direction? If you remember, frictional force is mu times mg provided body moves on horizontal surface. If it is moving on inclined surface, in that case mg will be replaced by mg cos theta. So it will become mu mg cos theta. So P minus mu mg cos theta plus mg sin theta will be net force, and then work done can be calculated by multiplying by distance moved to net force. So that is given here. Mg sin theta plus these two forces will be the opposing force. Frictional force is mu k mg cos theta, and the work done will be, as I told you, total force. So here in this question, total force is taken as just the two forces that are opposing. So opposing forces mg sin theta and mu k mg cos theta, as I have shown you. So work done can be easily calculated. Calculate the work done if a body of mass 20 kg moves through a distance of 1 meter on a rough inclined plane making an angle of 30 degree with the horizontal, given mu k equal to 0.10. So it is again simple, as you have seen in this case, work done. So this thing we have taken into consideration, this total, because this will be, here we have assumed that there is no net acceleration. If there is net acceleration in this direction, in that case P minus mg sin theta minus mu k mg cos theta will have certain value. But here body is moving with a constant velocity, it means the difference of the force applied and these two opposing forces will be 0. So that is why in order to calculate work done, we have taken into consideration mg sin theta plus mu k mg cos theta times displacement or distance. So here that concept is to be used. Work done will be mg sin theta. Theta is given as 30 degree, mass is given 20 kg, and g you can take 9.8 or 10, whichever is easier for your calculation. And mu k is given 0.1, and then theta you can put, and distance moved is given 1 meter. You can easily get the work done. Now here there is another case, acceleration of a body sliding down an inclined plane. Here we are assuming again that there is no force applied. So in this direction, since body is coming downward, so downward force, you know, mg sin theta, and in this direction there will be frictional force. Frictional force will oppose this force, so net force, you are not applying any force. Body is moving on its own. So mg sin theta will be opposed by frictional force. So net force will be mg sin theta minus friction, and you know that frictional force when body is on an incline will be mu mg cos theta. So you can say the force acting on the body which is taking it down is mg sin theta minus mu k mg cos theta. Now to find acceleration, you can divide it by mass. So you will get g sin theta minus mu k g cos theta. Here you have a question, a metal block of mass 50 gram when placed over an inclined plane at an angle of 15 degree slides down without acceleration. If the inclination is increased by 15 degree, what would be the acceleration of the block? So initial situation is given, a metal block of 50 kg when placed over an inclined plane at an angle of 15 degrees slides down without acceleration. So in first case it is an angle of repose. So we can evaluate, we are given mu. If you remember, I told you angle of repose is tan theta. So tan theta, theta is given 15 degree, and this value is also given. So you don't have to use calculator. So mu is this much. Now, if you want to find out acceleration, if the inclination is increased by 15 degree, what does this mean? Now angle becomes 30 degree. Earlier it was 15 degree, now further 15 degree is increased, so 30 degree. In that case, body will get certain acceleration. So in a downward direction, there will be force g sin theta, and in upward direction, there will be frictional force. And since you need acceleration, so you have to divide it by m. So you will get A equal to g sin theta minus mu k cos theta. Put theta equal to 30 degree and g equal to 9.8, and mu k you have already evaluated. So you can use this value. Now there is another concept. Friction is a necessary evil. Why? So necessary evil, it means without friction there will be difficulty. Grip and traction. Friction allows object to grip surfaces, providing traction for walking, driving and other activities. Control. Friction helps in controlling the speed and direction of moving objects such as vehicles on the road. Heat generation. This is negative effect. While it might seem like disadvantage, friction's ability to generate heat is useful in various applications. Positive effect is also there. Negative effect is also there. When machine parts rub against each other, then heat is developed. So that is wastage of energy. Wear reduction. Controlled friction can reduce wear and tear on machinery, providing a cushioning effect. Now, disadvantage: energy loss, wear and tear, then resistance in motion. Now, limitation in efficiency is also there. That is also one factor. Now, one important aspect. So here, it is easier to pull a body than to push. Why? So let's understand it other way around. Suppose this is an object whose weight is mg in this direction, and you want to pull it. You are applying force like this. This is F. So this F force has two components. One component, suppose this angle is theta along horizontal. So one component will be F cos theta, which will try to pull it in this direction. Another component will be F sin theta. This component F sin theta will reduce the weight of the body. So net weight to be pulled by F cos theta will be mg minus F sin theta. So this is case of pull. Now suppose we consider the case of push. In this case, what happens? Suppose pushing force is applied like this, and this is weight. So let's take it in this direction so that it may become clear. So this is suppose force F is acting. So it has two components. One component in this direction, suppose this angle is theta, so this angle will also be theta. So F cos theta will try to push the object, and another component of this F will be in this direction, F sin theta, and it will try to increase the weight. So this time net weight to be pulled by this force F cos theta will be F sin theta plus mg, whereas in this case net weight to be pulled by F cos theta was mg minus F sin theta. It means here in case of pulling, body becomes lighter by F sin theta, means weight is reduced by that factor, whereas in case of pushing, body becomes heavier by the factor of F sin theta. So we are adding F sin theta to mg. So definitely it will be easier to pull than to push. Same thing is explained here. If you consider friction also, so there will be another force. in addition to what I have told you. Now, circular motion of car on a level road. So we can see the situation. This is a road, and here normal reaction means weight of vehicles mg downward, and one reaction here is R2 on this wheel, another wheel has a reaction R1, and now take friction on this wheel is F1, friction on this wheel is F2, and the point that can be taken as a radius from the center of the car is here. This distance is taken to be R. So here friction will provide centripetal force. Do you remember what is centripetal force? So centripetal force that acts toward the center when body moves in circular path, and it is given by mv square upon r. So it depends on mass, velocity and radius. So here radius is r, mass of car is capital M. So we can easily evaluate, but before that we have to find out other things like weight of the body and normal reaction. So you can say mg will be equal to r1 plus r2. This is one point. And we consider the friction between the tires and the road. So here F1 will be mu times R1 and F2 equal to mu times R2. So total friction will be mu times R1 plus R2. Now we have mg equal to R1 plus R2 and friction is mu times R1 plus R2. So either we can put this value in place of R1 plus R2 as mg. So Fr will be mu mg. So when we put this value here, R1 plus R2 equal to mg, so we have got Fr equal to mu times mg. But this frictional force must be greater than or equal to centripetal force, so that this car can take turn easily. So we can say mu mg must be greater than or equal to mv square upon r. Here our concern is to find the velocity. M can be cancelled, then v square will be less than or equal to, here m is cancelled, mu rg, or v is less than or equal to root of mu rg. So from here we can evaluate what should be the minimum velocity with which car or a vehicle can take turn safely. So let's see one question. Question says a bend in a level road has a radius of 100 meter. Find the maximum speed with which car turning this bend may have without skidding. You have to find out the maximum speed that car can take, and it can take turn without skidding if the coefficient of friction between the tires and the road is 0.8. So here you have to apply this formula. V is less than or equal to mu rg. Radius is given 100 meter and mu is given as 0.8, and then you can put the value of g as 10 or 9.8. You will get the speed. Now, banking of curved road. What is that? Banking of curved road means one side of the road is raised by certain angle. So banking of a curved road, also known as camber or super elevation, refers to the sloping of the road surface along a curve. This sloping is such that the outer edge of the road is higher than the inner edge. Banking is designed to facilitate safe and efficient travel around curves, particularly at higher speeds. So there is angle of banking. The angle through which the outer edge is raised above the inner edge is called angle of banking. Causes of banking. This banking provides centripetal force. When a vehicle travels along a curved path, it experiences a centripetal force directed towards the center of the curve. This force is essential for keeping the vehicle on the road and preventing it from skidding outwards. Banking the road helps provide the necessary centripetal force by utilizing the component of the vehicle's weight perpendicular to the road surface. We will do this in mathematical way, so thing will become very clear. Friction, banking also helps maximizing friction between the tires and the road surface. The sloping of the road surface helps distribute the vehicle's weight more evenly across the tires, increasing the available friction and improving the traction, especially during turns. And it is necessary for safety purpose also. Properly banked road reduce the risk of vehicles overturning or losing control when navigating curves, particularly at higher speeds. By providing the necessary centripetal force and enhancing traction, banking contributes to safer driving conditions. The efficiency, banking allows vehicle to navigate curves more efficiently by reducing the need for excessive steering input and speed reduction. This helps maintain a smoother flow of traffic and minimizes energy consumption. Now we are going to derive the relation. We are going to see what is the formula. So here you can see there is a car. This is banking. Here outer raise is raised by angle theta and the car is here. Friction is acting in this direction and weight is acting in this direction, normal reaction is acting in this direction. So here normal reaction is perpendicular to the surface. So here normal reaction is n. If this angle is theta, this angle is theta, so this will be n cos theta, which will be balanced by mg. And also keep in mind friction is in this direction, so one component of friction will act in a downward direction. So weight mg and f sin theta will act in downward direction and n cos theta will act in upward direction. And here there will be centripetal force, that is mv square upon r. Here centripetal acceleration is shown v square upon r. So if you analyze it in detail, so you can see the same thing that here if friction is in this direction, this angle is theta, and then f cos theta will act in this direction, and here the same thing is shown that mg is in this direction, f sin theta is also in this direction, n cos theta this. So we can write these all components. If it is not clear, then I will write it further. So here I can make thing easier. Object is here and its normal reaction will be perpendicular, and then its weight will be like this downward. This is mg, this angle is theta, friction will act along this line, this is friction, and centripetal force will act in this direction. So you have to find out that what is providing centripetal. If this is normal reaction and if this angle is theta, so n cos theta will act in this direction and n sin theta will act in this direction. So this is one component of normal reaction that is providing centripetal force. Also, if this angle is theta, this is friction, this is also theta, so one component of friction will also provide centripetal force. So you can say in this direction Fr, this angle is theta, Fr cos theta will also be there. So you can say that n sin theta plus Fr cos theta will provide centripetal force, and n cos theta will be balanced by mg and one component of friction, that is, since cos theta component is in this direction, so here it will be sin theta component Fr sin theta. So you have seen the situation. N cos theta is balanced by Fr sin theta plus mg. So same thing, it's given n sin theta plus f cos theta equal to mv square upon r, which is centripetal force, and n cos theta, that one is balanced by f sin theta plus mg. Or if we want to retain mg in RHS and f sin theta, we can take in LHS. So n cos theta minus f sin theta equal to mg. We have got two relations. Now, if we divide the two relations, what do we get? So here n sin theta plus f cos theta divided by this thing, n cos theta minus f sin theta. So that is written here, and here mv square upon r divided by mg. So mv square upon r times mg. So m will cancel out and v square upon rg will be left. So that is written here. Now, what we can do further? If we divide each term by n cos theta, what would be left? Here n cos theta will give sin theta upon cos theta will become tan theta, n will get cancelled. So we will get tan theta, and f upon n. This term will become f upon n, and f upon n is coefficient of friction. So in that place, f upon n times cos theta. So we will write first here f upon r cos theta will cancel out, and that will become mu. We can directly write, and here also f upon n can be written as mu, and this will become tan theta, and this will become 1. So what do we get? So we can say we have got tan theta plus mu divided by 1 minus mu tan theta equal to v square upon rg. So we have got the relation. Our concern is to get velocity. So v square will be rg times this value, tan theta plus mu divided by 1 minus mu tan theta. Now from here we can write the relation of velocity will be rg square root of rg times tan theta plus mu divided by 1 minus mu tan theta. Now we can consider the situation. If theta is 0, then what happens? If mu is 0, then what happens? So if theta is 0, then tan theta term will vanish. So we will get v equal to rg times mu. And if mu is 0, then this term will vanish, and we will get v equal to rg tan theta. So these are the two cases. So I think you have understood. So when there is no friction, mu will be 0, then we will get that relation, as I have told you earlier also. Now, next example, here in our question, it's given that a circular racetrack of radius 300 meters, so value of r is given, and the angle of banking is given as 15 degree, coefficient of friction is given as 0.2. So what is the optimum speed of the race car to avoid wear and tear? So to avoid wear and tear means mu is absent. So remove mu from previous formula. When mu is absent, then rg tan theta can be applied. So for first case, you can apply rg tan theta. Now in the second case, maximum permissible speed to avoid slipping. It means mu is to be considered, and angle of banking should also be considered. Then formula will be v equal to rg tan theta plus mu divided by 1 minus mu tan theta. We can put the values to get the answer. That will come out to be 38.1 meter per second. Now there is another situation, that is bending of a cyclist. When cyclist goes around a curved path, then when cyclist goes around a curved path, a centripetal force is required. The force of friction between road and the tire is not enough to do so. When he leans toward the center of the circular path, the horizontal component of the normal reaction provides this centripetal force. So here situation is shown. Here this is cyclist. He is taking turn. So here bending is shown by angle theta with the vertical. So at this point, if you see, so weight mg is acting in downward direction, and component of R is in this direction, normal reaction. So R cos theta is balancing it. So you can say R cos theta is balanced by mg. But we need centripetal force. So here R sin theta component of normal reaction will provide centripetal force. So R sin theta will be equal to mv square upon R. Now again you can divide. So second divided by first. So tan theta. So tan theta will be, m will cancel out, v square upon rg, or v square equal to rg tan theta, from where we get v equal to root of rg tan theta. So this is the case of cyclist. Same thing is explained here, r theta equal to tan inverse v square upon rg. Here question is given, a motorcyclist goes around a circular race course of diameter 320 meter at speed 144 km per hour. How far from the vertical must he lean inward to keep his balance? Again the question is same. Speed is given in kilometer per hour, so that must be converted into meter per second. That is one important point. Radius is just half of that value, that is 160 meter, and then you can apply the formula tan theta equal to v square upon rg, and you can get the value of theta. Then there are two types of frames, inertial frame of reference. An inertial frame of reference is a coordinate system in which Newton's first law of motion holds true. This law states that an object will remain at rest or in motion unless acted upon by an external force. In other words, in an inertial frame, there are no forces acting on an object unless it is accelerated. Example, a person standing still on the ground, a train moving at constant velocity, a spaceship coasting through deep space with its engine turned off. Then comes non-inertial frame of reference, accelerated frame. So later on, like car accelerating or decelerating along a road, an observer inside a rotating amusement park, right? A passenger in an elevator accelerating upward or downward. In such cases, Newton's law will not apply. As you have seen in this case, it's a given that Newton's first law applies. Here there will be extra acceleration because it will be acted upon some other forces also. So different type forces like fictitious forces like centrifugal force will be there, Coriolis force can be there, Euler force can be there. So these forces will cause the inapplicability of Newton's law, and in case of non-inertial frames, object may appear to accelerate even if no external forces are acting on them. The path of moving objects may appear curved even if they are moving in a straight line, and objects may appear to experience additional forces that are not present in the inertial frame. So understanding the distinction between inertial and non-inertial frames is crucial in many areas of physics, including classical mechanics, general relativity, and fluid dynamics. It allows us to accurately describe and analyze the motion of object in different frames of reference. Then there are certain questions for your practice you can do, or you can do questions from NCERT textbook. So this is all about this lesson. Thank you, Team Educate.